So this goes into one of the rules with sine and cosine. It is that complementary relationship. It actually has nothing to do with SOHCAHTOA. It's more about the relationship between sine and cosine. So if you remember, just I'm gonna write something. You don't need to write it down, but things like the sine of 50 is the same thing as the cosine of 40. If you plug these two in a calculator, you'll get some decimal number. You're going to notice that they are the same decimal number because these two values are complementary. They'll always add up to 90 degrees, so they're always equal such that they equal 90. So we can utilize that rule just taking this expression here, the 46, that they must add up and give you 90 degrees. So right off the bat, you know that this has to be 44. So that's kind of one way you can think about it, because 44 plus 46 equals 90. But the way we've done it in class was we just took the two expressions, 2x plus 4 plus 46, and set it equal to 90. That's how you do that one. A little deceiving because, yes, it uses sine and cosine, but it had nothing to do with SOHCAHTOA. So hopefully that helps. I trust you can do that algebra. Perfect. So we're probably going to go over, we'll finish this page today. Again, maybe not all of it, but most, we won't do every example, but we'll do this page. And then on the next, definitely want to go over some arc length because that is new. So hopefully we'll finish up central angles today. We might even finish a little bit more because these aren't, I don't think, terribly difficult. So I think these examples will go by pretty quickly. And then we all get to a homework, 10-2. I'm not going to assign this. You guys have an assignment already. At some point, can we see the last night's homework? Yeah, I can put it up now because I'm sure I'll be talking first. So here's an answer key to it. Just take, this is an important note up here, that some of them do have multiple answers, so just be mindful of that. So if you have a question, if you have something different than the answer key, just let me know. Everything else should be pretty standard. It looks like everything is rounded to the nearest tenth. Some are rounded to the nearest hundredth, but if you rounded to the nearest tenth, that's fine. The directions don't specify. But just kind of as a general announcement, tomorrow your weekly is due. I don't think I've gotten any turned in just yet. So that's kind of your assignment for the week. I've gone over a lot of the questions on stream. So if you've been here watching the streams, you should have probably 7 out of 10 of them answered already. If you've been here, for every minute, because I've gone over a lot of them. And I'm fine with that. That means you're here, you're paying attention. So that's a nice, easy assignment, and I'll gladly do that each week, each assignment, whatever it is. So So just make sure you guys get that in tomorrow. I'll likely grade it over the weekend, get it back to you. Remember, I'm grading them with a good amount of leniency. So I'm grading them kind of closer to a homework, weighting them more. So it was a huge benefit to your grade by just handing it in. How you doing? Good morning, Gavin. But I think that's really the only thing that is due. The Mrs. McGruff should be going to the school either later today or tomorrow to prepare everything that is supposed to get sent home. I'm getting a lot of questions. When are you getting the hard copies to this? Soon. I'm thinking early next week, maybe around the 21st or 22nd. It should be when they get delivered to your house. We haven't gotten any emails or we haven't heard anything, but it should be soon. So I think that's all the general announcements I have. I'll throw up the other page to the answer key for anyone who took a practice it perhaps and just taking a look on your own. But those are the answers to the second half of the homework sheet, which I didn't assign. It was just for extra practice. No, there's no specific time. I don't think I can put times for Google Classroom, but as long as you get it in by tomorrow, I'll probably take a look at them on Saturday. So you just get them in, or as they come in, I'll probably grade them. But as long as you submit it by Friday, it is considered on time. So no specific time, just 11:59. I think that's what Mr. O'Brien does as well. 11:59 p.m. So right before midnight. All right, let's jump in right where we left off yesterday. So we're kind of looking at central angles. And we're gonna just practice another one, pretty easy one, just to kind of refresh our memory from yesterday. Just take a look at the stream when it ends, which today I'm doing calculus. It's going to end around 2 o'clock today, or you can just watch it on the YouTube. I've been putting the solutions on YouTube for anyone who wants to see them. So, a lot of answers out there for that weekly, so you'll be able to see that. And someone's offering their help as well. That's awesome. All right, so we are looking at central angles, and obviously the most important thing with central angles is the fact that their arcs are going to be congruent in arc measure. So if I'm taking a look at this central angle right here, it is 87 degrees. That makes this out here 87 degrees as well. And it works backwards as well. They give you another angle out here, which is 72. So we can actually just take this 72, and the central angle is also going to be 72 in there. And then from that, we're kind of expected to figure out everything else. And I think we have plenty of information where we can start figuring stuff out. We have vertical angles. The 87 is not vertical, though, so be careful. Angle X is not 87. Whoops. It's not 87 because this is not a perfect vertical angle pair, because the line does stop. But the 72 degrees is vertical, so that one is good, which means UV, the arc UV right here, is also going to be 72 degrees. And then, in order to figure out the rest, we have linear pairs. So this is a linear pair right here. So they must add up to 180 degrees. So 72 minus 180, what is that? 108? I keep doing that. $108. And then we have every angle in the circle except that small one right there. So we can figure out that angle. You have a few options here. You can add up all the angles, subtract from 360, or these three angles right here must add up to 180. So you have either option that you can take in order to figure that out. I'm going to do the 180 one because I add these two together. That's 72 plus 87. That's 159. Subtracting 159 from 180, you get 21. So all five angles? All five angles must add up to 360 degrees if you want to check it. And then I also have a few more central angles and their arcs I can label. So ST out there, it's 21 degrees. And I also have WV down here. So I have every individual arc and every individual angle labeled. So now whatever they ask me over here should be nice and easy. You might have to add or subtract some angles and arcs, whatever. That's fine. But if you have all the individual angles, you'll be able to figure it out. So the first one says angle UXV. UXV. So here's UXV. Pretty straightforward. 72 degrees. Arc ST. So arc ST is this little one right here. Again, it's only two letters, so you assume it's the minor arc. So that's 21 degrees. Then it's arc WV. Arc WV is 108 degrees. All right, yep. Then it's arc TW. So TW. So now TW goes this way. You do not need to consider that S in there really. It just ignores it, but we do assume the minor arc. So we do need to add these two together, the 21 plus the 72, to give us 93. And then the very last one, which is arc TVW. And then we just remember for this, we go in that order. So you have to be mindful of all three letters simultaneously. So T, V, and W. So I start at T, and then I have to think, well, do I go clockwise or counterclockwise? Because you have to hit V first and not hit W. And in order to do that, I have to go clockwise around this circle. So T, V, and then end at W. So it is all of those angles. And it's actually kind of nice that we found out that that yellow one is 93 because the orange one is everything else. So you can actually just take 360 and minus 93, or you could add up 87 plus 72 plus 108. If you do that, what are we getting? It's I want to say 67. Yeah, that's right. 267. So you just got to take your time. So step one, it's just like anything else we've ever done in the class, really, in geometry. You fill in the diagram with all the possible information, and then you can just see, all right, what are they asking for? And then we could fill it in. We'll try one more. We'll do, I suppose, a more difficult one. So we'll jump right to number 4. It's snowing like crazy outside for me. I don't know if it is by you guys. It probably is more so for you. But it is snowing. All right, let's take a look. So they only give us really two pieces of information, the 19 degrees and that right angle. So we got to keep that in mind. So first thing I would label is, well, TS must be 19 degrees because of central angles. That's the whole rule that we're using. We do have one pair of vertical angles in here as well. This right here must also be 19 degrees for vertical angles, which makes arc QR 19 degrees. So let's see what we can figure out from here. Two things stand out to me from here. This angle and this angle, they both stand out. This one right here must be 90 degrees because it's right next to another right angle and it's across the diameter. We can see the flat line right here, so that 90 plus 90 must be 180. And then the other angle that's kind of getting cut by that 19 degree side, we could just subtract that from 90 because those two angles must be supplementary. Sorry, not supplementary, complementary. So 90 minus 19, was that 71? Yep. And then that makes this out here 71. That makes this arc 90 degrees. And then we only have one angle left, which is angle U. Let's see, is angle U vertical to anything? No, it's not. It looks like it's just a linear pair. I would use these two angles right here. You have that nice linear pair, especially right across that diameter. So that makes it nice and easy. So that we can subtract from 180. And to get this angle, RUS, that will be 161. Which makes the arc 161. So all we need to do now, I think we have everything labeled. We do. So now we get to, let's see what they want. PQ, pretty straightforward. PQ is right here. So PQ is 71 degrees. SR, arc SR. So SR is right here. Again, using the minor arc, going that way because I'm going to the 161. So 161 degrees. Arc QRT. So QRT, again, being mindful of the fact that you're going to hit those letters in that order. Q. So I see R right next to it, so I can go right to the R, and then T wraps all the way around past the S, going right here. So there's QRT. You have a 19, a 161, and another 19. Well, we already know the 19 and 161 is 180. So it's 180 plus 19. So that would be 190, 199. PSR. So here's P up here. So now in this case, I can't go clockwise because I would hit R. So now I have to go counterclockwise to hit S first. So P, S, wrap around, hit R. So it's everything but that 71 and 19. So that's actually, that's literally 75% of the circle. That's going to be 270 degrees. You can just add them up. 90 plus 19 plus 161. That's going to be 270. And then the very last one, PS. So here's P, here's S over here. So that's going to be, that's pretty straightforward. 90 plus 19, 109. And those are the ones pretty much that are straightforward, at least, no algebra, nothing like that. Because the ones we're about to get into are going to require some algebra. We're going to see some x values, write an equation and find an angle, plug back in, or something like that. So here we have just, I think, pretty straightforward. If you guys have questions, throw them in chat. But we'll move on to 15. Sorry, not 15, 5. I don't know why I said 15. Probably because I'm looking at that 15x. So I'll give you a second to copy it down. Pretty easy diagram. It just says find each value or the measure that they want. They just want the value of x. So the best way to figure out the value of x is to figure out what this arc measure is going to be. So let's figure out what arc RS is supposed to be. So we're going to use that 26 degrees down there, and we know if we have that 26 degrees, we probably could find every arc, every angle in this diagram. What we just want to know is what's the measure of arc RS. So I'm going to ignore the 15x minus 26 for now. I'm really going to utilize the 26. So 26, well, here we have, you have a central angle. You can find the linear pair this way, which is going to be 154, which means the arc is 154. Because all these numbers are the same. I mean, you could even use the whole semicircle right here. There's a half circle right here, and you know that's 180 degrees. You could just automatically subtract from 180 from step 1. So that means the arc is 154. And once you know the arc measure and you have the expression, set them equal to each other. That's it. So we're going to set 15x minus 26 equal to 154 degrees. So it's actually pretty easy, especially because we've used 26 already. So we know 26 plus 154 is 180. Divide both sides by 15. And we get an answer of, what is this going to be? I think it's 12. You guys can correct me if I'm wrong. Ryan's saying 12, so I'm going with it. 12 looks good. And we don't need to plug back in. It doesn't say that we need to plug in. And you can kind of see it would be pointless to plug in anyway, because we know the value of the arc. Because if you plugged in, you're just going to get 154. So it's really no surprise why they're not asking us to plug in. Is it okay if we just added 15x minus 26 plus 26 and set it equal to 180? Absolutely. That's a different way of setting it up, which I didn't even consider. So Paige is using the entire semicircle and just saying, well, the semicircle adds up to 180, so 15x minus 26 plus 26, set it equal to 180. Absolutely. That would definitely work. Absolutely. You're just utilizing different properties of the circle. There's definitely going to be more than one ways. There's going to be several different ways we probably could consider a lot of these problems. But I like that. And that's fine. If that's what you do, you should do whatever kind of comes naturally to you. I just did what came naturally to me when I did it. And that's typically how I'm going to do these. So let's see how we can analyze this one and see maybe if some people do something differently. We'll see. So we are given that 18x minus 2 is the expression. We want the value of x. That's going to be our answer. So the goal is let's figure out whatever this arc measure is, or whatever that angle is, because we know they're the same. So we find one, you have the other. So we have to utilize the two numbers we have, 15 and 103, to figure out what that angle is. So I know a few things. Well, this is 15 in here. This is 103 in here. And then I want to see where I can go from there. And it looks like that 103 is a linear pair to both this angle and this angle. So that would be the first thing I would do. Because if you know it's a linear pair and they're vertical, that gets two angles right off the bat. And then you'll have all the angles except the one that you really want. So those angles right there are 77 each. And now you have every angle except this one that's the one we really need because that's the arc. So you can add them all up, subtract from 360, or we can utilize the fact that, well, here's a diameter, So everything on the left-hand side of the semicircle must add up to 180 degrees. I'm going to do that one. So 77 plus 15 is 92. I'm going to subtract that from 180. So I get 88 for this angle. So, looks good. I think that's right. And now that if that's 88, that makes the arc 88. So now we can just set them equal to each other. So 18x minus 2 is equal to 88 degrees. Nice, easy algebraic expression for us to solve. Add 2 to both sides. 18x equals 90. And I'm just guessing that 90 divided by 18 is 5. Yeah, it is. No plugging in required. Looks good. So really we're just using new rules that we haven't used before because, this is the first time we're kind of seeing circles. But it's a lot of what's 180 degrees, what's 90 degrees, what's 360. It's still a lot of the same rules that we've used all year. Linear pairs, vertical angles. It's still a lot of that stuff. And everything kind of just chains off of each other. So if you've been comfortable with problems like that, this really shouldn't be any different in that regard. All right, in number 7, now things get a little bit different because now they're going to start wanting some arc measures and or angles. Looks like they want 3 different arcs as our answer, as well as a value for x. So we need a variety of answers, and they give us no numbers, which makes sense. If you knew one of the numbers, you can figure out everything quite easily. So we need to figure out the relationship between these 2 arcs. And it's quite easy because of the fact that these obtuse angles right here, they're vertical angles. So if they're vertical angles, their corresponding arcs, this arc and this arc, must be congruent to each other because they're central angles. So the central angles make these 2 arcs congruent. So therefore, you probably guessed it already, we can just set these 2 expressions equal to each other. So we're going to take 10x, 10x minus 22. We're going to set it equal to 8x plus 12. Add 22 to both sides, subtract 8x. So let's do all that. We get 2x here. The 22's cancel. The 8x's cancel. And then we get 34 equals 2x. So we just got to divide by 2. And we get x is equal to 17. So I'll put that answer in this blank right here. And then they want me to find 3 different arc measures. So just like always, I'm not concerned about those 3 things right there right now. I'm more concerned, let me just fill out the entire diagram based on this value of x. And then I can go back and then just plug in whatever I want. So the only way we're going to do that is we got to plug in 17 for one of them. It doesn't matter which one. We know they're going to be equal. It's a good way to check. As always, if you plug in for both, do you get the same value for x? Hopefully you do. I'm going to plug in that one because 10 times 17 is pretty easy. So you get 10 times 17 minus 22. So 170 minus 22. This arc is 148. Which means this arc over here, also 148. And then their corresponding arcs next to it, A, B, and DC, they're just going to be supplements. So we're just going to subtract from 180. And these two arcs are congruent because they're vertical. So a lot of symmetry in this problem. And I think we just get 32. If there's any confusion on how I'm getting these numbers, let me know, because there's quite a bit of mental math going on here. And I know I'm a little quicker with the mental math. But if you understand how I'm getting them using the linear pairs, supplementary, the half circles are 180 degrees, you'll be fine. Now that we have everything labeled, and their corresponding angles in here they're all the same. I don't think we need these though, but it's true. Now we can fill in whatever they want. So arc AD, that's 148. The next one they want is arc CD. That's easy. I already have it labeled right here. 32. Is that question for me, Ryan? Because I have no idea. And then the last one is BDC. So BDC, I'm going to have to go counterclockwise because I have to hit D first. So here's BD, then finish C right here. So it is everything but that 148 degrees. So you can do 360 minus 148. That's one way to do it. Or you have the half circle, 180 plus 32. Regardless of how you do it, you're going to get, I think it's 1 or 212. All right. So overall, central angles, not too bad. I'm going to flip over. I think I'm going to skip 8 and 9 because I want to jump to arc length. We can start it today, continue it tomorrow to practice, and then maybe practice some of these homework problems. I think that would be a nice way to end the week that we've done quite a bit so far this week with our new unit. So I'm going to jump right into arc length. And we have the arc length formula already. It is in the, when we did the definitions, which I can pull up quickly right here. It is over here. So I am going to be writing down the same exact formula. X over 360 times 2 pi r. So now that we've found the measures of all these arcs, recall, we've only found them in degrees, but all of these arc lengths have an actual length to them. So if you can imagine, if the circle was made out of like string or something, if you were to straighten out the string and then measure it with a ruler or something, they all have their individual length, and that is completely independent of how many degrees they are. But knowing how many degrees they are helps us figure out what that length is going to be. And the way I've always kind of tried to remember this as the best way to figure it out is it's a percentage of the circumference. It's always a percentage of the circumference. Would that formula be on our reference sheet for a Regents? I don't think so. Do I have a Regents up here by any chance? I do. This is what you get for the Regents. And the only thing they give you close to it is they do give you area and they do give you circumference. And I know some of you are thinking, like, well, you don't have a Regents, so does it matter? It doesn't, but it's the same reference sheet you would get for Algebra 2. But it's a good question. And the answer is no. But if you know how to take the circumference and we think about it in terms of a percentage, it's a lot easier. But I know we're not taking the regions. I will still reference it sometimes because those are the kind of the standards I want to still teach you too. One thing I am going to do, I'm going to talk to Mrs. Chambers closely, and I might alter some of our next unit to really tie in stuff that you'll learn next year, so you have an easier time next year rather than because we have that time, we have that availability. But I will talk to her and see maybe what topics might be best for you guys to learn that ties in a little bit of geometry and algebra too. But our formula is L equals. So the percentage part, and you see it right over here to the right, it says the degree measure of the arc, which we're calling x, over 360. And that's just a percentage. That's the percent part of the formula. Times, they use C for circumference. You can use C, you can use 2 pi r, you can use pi times d. I like using 2 pi r, but it really doesn't matter. If you know the circumference, this is just C. And this part is just a percent. So it's literally percent times circumference. And we know a percent, you can't have more than 100% of a circle. So these values are always going to be smaller than the circumference of the circle, and that should make sense. If it's a semicircle, and we've done stuff with a semicircle before, we've taken circumference and you literally cut it in half. That's 50%. So that's just how this formula works. And if you kind of understand that's how this formula works, that's why you do not need it on the reference table. You're just taking the percent, multiplied by the circumference, you have your length. So we're going to do that right here in number 10. So it says if EB equals 15 centimeters, it says find the length of arc CD. And this is where you really need to read the language of the problem, because in all the other questions we were finding the degrees, but now they use the word length of arc CD. They're not saying the measure in degrees, they're not saying anything like that. Because they're using the word length, this is how you know it's automatically going to be that proper equation that we just wrote up here. We do need to know how many degrees that arc is. So I'm going to see, where's arc CD? So arc CD is right here. I want to know how long that arc length is. So I need to first figure out, I got to find that central angle so I can figure out what that arc value is. So that's pretty easy. This angle right here is just a supplement. So 68 minus 180 is 112. So that makes this 112 degrees, which is not the length. It's just the degrees. So what we want to do now is we're going to plug in to the formula. We also know that right here that EB is 15. Where's EB? EB right here is 15 centimeters, which is good. That's the radius of the circle. That's kind of what we want because that ties nicely into 2 pi r. So we're going to leave that 15 centimeters right there. That's the radius. We don't really need to do anything with that right now, but we're going to plug in. So I'll write out the formula. X over 360 times 2 pi r. So the length, which in this case, that's the length of CD. X is the arc measure, so 112 over 360 times 2 pi r. 2 pi times the radius, which is 15. So I'm going to take my calculator out. Oh, I don't think you guys can see that. Let's see. Should be able to see it now. I'm going to do the 112 over 360. Now, you could type this into a calculator in one shot. I'm just going to take it step by step so we can kind of have a little bit of an understanding on what we're doing. So that 0.31, I'll do that again. I'm doing 112 divided by 360. And what this number tells me, and it is 31.1% of the circle. So 0.31 repeating. That's the percentage piece. You're literally taking 31% of the circumference of the circle. You could do 2 pi r separately too. So 2 pi r is 2 times pi times the radius. This number right here, that's the 2 pi r part. That's the circumference of the entire circle. 247796077. Like I said, you don't need all these numbers written down, but you can see how the formula gives you, here's the percentage piece part of the formula, here's the circumference piece of the, part of the formula. So you have a little bit more information if you were to just plug it all in a calculator at once. But now I can multiply it by that percent, 0.31, and then since it's repeating, I'll hit 1 until my calculator can't do it anymore. Hit enter, and I think the directions do tell us around nearest hundredth. So we will do just that. And that is our answer. So the length is equal to 29.32. And what was it, centimeters? Yeah, centimeters. 29.32 centimeters. So hopefully that formula makes some sense. That part is definitely new. That is definitely something you have not done in the past. So that is what we are going to be looking at practicing more tomorrow with the rest of these examples on here. So we'll be practicing using that formula. And we can do the same exact thing with area, and we will do that as well. We call it sector area, which is percent of the circle times the area. And that could help you figure out the area, kind of like the area of a pizza slice or something like that. And we will do that in the future as well. But we only got a minute left, so that's not enough time to do another example. That's a good time to end. I'll stay on. I'll be on for 20 minutes before my physics class starts. But we are all done for today. Thanks for coming. I'll see you tomorrow. Have a nice day. Tomorrow's Friday.